one very important thing that you have to understand when working with Rust, as well as many other programming languages, is this idea of scope. So in the previous example, when we had the fundamental data types and we declared these variables, then the kind of unspoken rule was that these variables, like this variable a, for example, would only exist in the scope where it is declared, meaning that because it was declared inside this function, it would only exist for the duration of this function. What this implies in practical terms is that this variable, which we declared in some function, is not available if you try to print it in some other location. So, for example, if I try to print line the variable a here, I will not be able to compile this application because there is no variable a in the particular scope inside this function. It's been declared in a different function, it's gone out of scope, it's been destroyed, and you cannot access it here. And this embodies the notion of scope. The variables have scope, they have a range of effects. So a only exists in the scope of the function. As soon as you leave the function, a ceases to exist unless you allocate it on the heap and return its address or something to that effect. Okay, so what do we need to know about scopes? Well, a function or anything that opens and closes the curly braces effectively creates a scope, and you can actually create a scope just by using the curly braces without any other additional instrument. So let's take a look at an example. I'm going to have a function called scope and shadowing, and this is a function that I'm going to have up here, for example, scope and shadowing. Okay, so here it is, and let me give you a very simple example. Let's suppose we have a variable a with a value 123. Now this variable exists throughout the entire scope, and we can print it. So we can print line once again. We can print a is equal to, and then give it a value a, and I can just run this and get my value of a, 123. That's easy. Now what I can do, as I said before, is I can use curly braces like this to create a scope, which kind of delimits an area where some variables would also exist. So inside the scope, I can have another variable called b. So b can have the value 456, and inside this scope, I can do anything I want with b. For example, I can print it. So I can say print line. I can say inside b has this value, and this is going to be just fine because there is no problem. I declare the variable, here it is inside the scope, it has the value 456, and as I leave the scope, what happens is b is no longer available, which means that if you declare b inside the scope, you cannot suddenly start printing it outside the scope, which means we cannot do something like this. We cannot say that, oh, here is b outside the scope. If you try to compile this once again, you're going to have a problem from the compiler, unresolved name b, because the name b exists only between these curly braces. It doesn't exist at this particular location. So this is the basic gist of what scope is about. Now we also have this rather dangerous effect called shadowing, because you see this variable a exists throughout the entire scope. It also exists in this inner scope as well, which means that inside in here I can actually print this variable. So let's copy this. Inside I can print the variable. So it doesn't really matter if it's inside or outside, it has the same value. But here it is, inside a has the value of 123, and then outside it has obviously that same value because we didn't really change it. However, one unpleasant trick that I can do is I can declare another variable which is also called a in the inner scope. Now, if I try to declare another variable called a in the outer scope, like if I said here, let a equal 777, this would not work because you cannot have two variables. Oh, wait, actually you can, apparently. Oh, here we go, yeah. So apparently the further declaration overrides the previous declaration, which is very unusual because in many programming languages it just gives you an error. But here we seem to have been able to redeclare the variable and everything is fine. Well, what you can do similarly is you can redeclare this variable right inside the scope. So I can have the variable a here with a value of 777, and now something interesting happens, because the inner a and the outer a actually have different values. Let me show you. I'll put outside here. So as I run this, let's wait for a moment. As I run this, inside a has the value 777, but outside a has the value 123. So what this means is that this a and this a are two entirely different variables. They have the same name, all right, but this variable, the inner variable, kind of shadows the outer variable, because if I didn't have this, then the a would refer to the outer a, but because I have this declaration, it now refers to the inner a. So this is pretty much all that I wanted to mention with regard to the variable declarations and scopes. And it's very interesting that you can apparently redeclare a variable with the same name and a different value and have it actually print out the updated value. So this is something you wouldn't find in many other languages.